Marhaba. Okay, in this session we want to learn a new technique in counting the number of ways of accomplishing a task. Remember, in the previous session we learned about the product rule, where in the product rule we have a mission that we want to accomplish, and we can break down this mission into several steps, and then we see in how many ways we can accomplish each step, and at the end of the day the number of ways to accomplish the whole mission is equal to the product of the number of ways to accomplish each task. Okay, now we want to learn another technique which is called the sum rule. And here in the sum rule we only have one task, to a single task to accomplish. Okay, so here you see we have only one task to accomplish. And now suppose this single task can be done either in m ways or in one of different n ways. Okay, so notice here different is important in the sum rule. Then to do the task there are m plus n ways. Okay, so let me say it quickly again. We have a single task to accomplish, and to accomplish this task either we can choose m ways or we can choose one of another different n ways. Then the total number of ways to accomplish this single task is m plus n. Okay, so let me give an example now. So suppose, for example, the task you want to do is choose a drink. So choose a drink, and to choose a drink there are two baskets. Suppose you are in a hotel in the breakfast, and you can either choose a hot drink or a cold drink. And to choose among the hot drinks you have only two choices, tea or coffee. Okay, and among the cold drinks you either can choose water or orange juice or apple juice, say. Okay, and what is your task is just to choose a drink. So to choose that drink you can either choose a hot drink or a cold drink, and notice that the hot drinks are completely different from the cold drinks. Since here we have two choices, which are tea or coffee, and here we have three choices, which are water, orange or apple juice. Okay, then we can choose a drink in total, so we have 2 plus 3, which are 5 choices to choose a drink, for a drink. Okay, so in how many ways you can choose a drink? In 5 many ways. Either you choose tea or coffee or water or orange or apple. Okay, as simple as that. This is the sum rule. And notice here again we are talking the m ways are completely different from the n ways. So here the hot drinks are different from the cold drinks. If you want this set intersection, this set is empty. So the intersection of hot drinks and the cold drinks is the empty set. In other words, these two sets, these two baskets are disjoint. Okay, so let's have another example. So here you are asked how many different choices are there if you are asked to choose a word which is a weekday or a month. So what's the task? We have a single task which is what? Choose a word. So we need to choose a word. Okay, let me use blue. So we need to choose a word, and to choose this word you have two baskets to choose from, either weekdays or months. And to choose a weekday, how many choices we have? Well, what are the weekdays? We have from Sunday, Monday up to Saturday, and here we have 7 choices in this basket. In the weekdays we have 7 choices, and in the month we have from January till December. Okay, and we have here 12 choices. So to accomplish the task of choosing a word which is either a weekday or a month, we have 7 plus 12. So we have 7 plus 12, which is 19 choices to choose such a word. So either you choose a Sunday, Monday, Tuesday up to Saturday, or you choose January, February, March, April up to December. Okay, so the answer to this question is there are 19 choices to choose a word which is either a weekday or a month. Okay. Now let's apply the sum rule to answer this question. What is the cardinality of the union of n many pairwise disjoint finite sets? So suppose we have n many sets, finite sets, so say A1, A2, A3 up to AN. And what do we know about these sets? They are finite sets. Moreover, we know that if I is not equal to j, that is, if you choose two different ones, then AI intersection AJ is empty. Meaning that no two different sets contain any element in common. Okay, so they are completely different. So now what is the cardinality of the union? So what is the cardinality of A1 union A2 union up to AN? So we want to apply the sum rule here, but remember the sum rule was only having two baskets of choices. Here we have n baskets. So let's see. What is the cardinality of this set? It is the number of elements of this set. So in how many ways I can choose an element from this set? So imagine we have, this is the set for A1, this is the set for A2, and so on. And why did I drew them in this way? Because they are disjoint. Okay, we don't have any element in common between any two. Now, okay, in how many ways we can choose an element? Sorry. Okay, in how many ways we can choose an element from this set, from the union? Now, what is the union? By definition, the union is the set of elements which are either in A1 or in A2 or in AN and so on. So either you choose an element from A1 or you choose an element from A2, and notice that the elements in A1 are completely disjoint from the elements in A2. So by the sum rule, the number of choices to choose an element from A1 or from A2 is the number of elements in A1 plus the number of elements in A2. And in general, or from AN. So I can choose either an element from A1, and in this case I have the cardinality of A1 choices plus the cardinality of A2 choices, because there are no elements in common. So either I choose any element from here or any element in here, and here I have cardinality of A1 choices, and here I have the cardinality of A2 choices, or the cardinality of A3 choices. So the set A3, and so on. So this says that the cardinality of the union of disjoint sets is the sum of the cardinalities of the sets. But this is very important, that they are pairwise disjoint. Okay. Actually, this is what we have done here, right? This is the set A1. What is A1? It is the set of weekdays, and this is the set A2. And we are asked to choose a word which is either in A1 or in A2. So the word we want to choose should belong to A1 union A2. And the cardinality of this is equal to the number of weekdays plus the number of months. And this is equal to 7, and this is equal to 12. So in general, in total, we have 19 words in this set, which is either a weekday or a month. Okay. Now, for the last question of this session, look, we have a computer system. and this computer system requires from the users to have a password. This password of this system has to satisfy three conditions. The password has to contain from 6 to 8 characters. So either it is a password of 6 characters or 7 characters or 8 characters. Second, each character is either a lowercase English letter or a decimal digit. So any character in your password, it's either an English letter or a decimal digit, which means a number from 0 to 9. So decimal digits are 0, 1, 2, up to 9. And English letters, lowercase a, b, c, up to z. Okay? So this is what, and notice that this set is completely disjoint from this set. Okay, so we have an OR here. I hope this reminds you of the sum rule. Okay, each password, also the third condition, each password must contain at least one digit. Okay, so how many possible passwords are there? Okay, so how to think about this problem? First, we want to see in how many ways we can form a password, because this will be the number of passwords. Okay, now let's look at number 1, condition 1. It says that the password must be of length 6 or 7 or 8. So let n, capital N, be the number of passwords, of all possible passwords. Okay? Now each password is either of length 6 or length 7 or length 8. So let me say P6 is the number of passwords of length 6, or which contain 6 characters. Okay, of length 6. And P7 is the number of passwords of length 7, and similarly for P8. Okay, the number of passwords of length 8. Now what is N? Look, now we applied the sum rule here. Why? Because to choose a password, your password has to be either of length 6 or of length 7, your password is either of length 6 or of length 7 or of length 8. Now, so the number of passwords are there is the sum of the number of passwords of length 6 plus the number of passwords of length 7 plus the number of passwords of length 8. This is by the sum rule. Why? Because any password of length 6 is completely different from any password from length 7. So the sets of length 6 is completely different from the set of passwords of length 7, and completely different from the password of length 8. So this means, applying the sum rule, we know that the total number of passwords here, the total number of ways to accomplish the task, which is choosing a password, is equal to the number of ways to choose a password of length 6, or to the number of ways to choose a password of length 7, or the number of ways to choose a password of length 8. Okay, so now we know this. It remains, so the question asks for n. It remains to find P6, P7, P8. Okay, so what is the picture here? We have here 3 baskets, and they are completely disjoint. And what are these baskets? These are passwords of 6 characters. So for example, 1, 2, 3, A, B, C. This is one of the passwords. Okay, here the passwords of 7 characters, and here the passwords of 8 characters. Okay, and what do we know? That the cardinality of this set, we call that P6, and this is P7, and this is P8. And so since they are disjoint, by the sum rule, we just sum the number of ways to choose a password of length 6 plus the number of ways, which is P7, to choose a password of length 7, and so on, and P8. So it remains to choose P6. Now what is P6? P6 is the number of passwords of length 6. So first imagine Now, how many characters we have? So what are the characters? To choose one character, in how many ways we can choose one character? Again, what is a character? It's either, now we apply the sum rule again here, it's either an English letter or a decimal digit. And here, so it's either A, B up to Z, or 0, 1, 2 up to 9. A character can be chosen either by choosing a letter or choosing a digit. So here we apply the sum rule again. Here we have 26 English letters to choose from plus 10 digits. So in total we have 26 plus 10, which is 36 characters. Okay. Now let's look at a password of length 6. So we have a password of length 6. Now I am applying the product rule. First, let me ask you the question, in how many passwords of length 6 which contain any character without the third condition that each password must contain at least one digit? Just tell me the passwords of length 6 which satisfy number 2, which is every character is either an English letter or a decimal digit. Okay, now we apply the product rule to form such a password. To form such a password, we need to do what 6 tasks, right? What are the 6 tasks? They are choosing the first character of your password, and here we have how many possibilities? We have 36. We need it to be a character, and the character is either a letter or a digit, and in total we have 36 characters. So here we have 36 characters, and for choosing the second character of your password we also have 36 choices, and here we have 36 choices, and so on. Every time we have 36 choices. For example, here is a password A. Here is another. Sorry, it's not a password in our question, it's just because every password must contain a digit, but a decimal digit. Here's another one, A, B, C, 1, B, and 9, okay? And so on. So there are how many strings of length 6 using the characters? There are 36 to the power 6, right? Now, I don't want all of them. So suppose here are all the passwords from 6 characters. We need the ones which contain at least one digit. So now suppose this part is passwords which contain only letters. So this means that, okay, so this means what I'm talking about, passwords of the form A, C, Z, X, Y, W. So this is a string of 6 characters only containing letters. Now we don't want these ones. We only want the passwords which contain at least one digit. So we want one which contains A, B, C, and then the number 4, X, Y. Okay, so this is a valid password. So which means we are looking for this part. Now this set, which all passwords of 6 characters, has 36 to the power 6 many passwords, but we want to remove from them these passwords which only contain letters. So how many passwords? So let's see, 1, 2, 3, 4, 5, 6. How many passwords contain only letters? So let's see. We apply the product rule again. Here I only have 26 choices because I want to see how many strings of length 6 which contains only letters. So I need to fill a letter here, and I have 26 choices. I need to fill another letter here. So here I have 26 choices, and so on. Okay. So this means there are 26 to the power 6 strings of length 6 containing only letters, and we don't want these containing only letters. Okay, so we need to remove them from the total number. So the total number is 36 to the power 6. What is this number? It is the number of strings of length 6 containing any character, either a letter or a digit. Now, if we remove them from them, the number of strings of length 6, which contain only letters, then what is left is the green region, which means, and this green region is our passwords. Okay, so this is our passwords. These are of length 6. These are the passwords of length of 6 characters, and they contain at least one character, one digit. So this means that P6 is equal to 36 to the power 6. These are the total number of strings containing any character, minus 26 to the power 6. And these are the ones we want to remove. These are the strings of length 6 which contain only characters. So what will be left? So this is equal to the number of strings of length 6 containing at least one digit. Containing at least one digit. Okay. Now, in a similar way of thinking, we see that P7 is the total number of strings of length 7 which contain any character minus the strings of length 7 which contain only letters. Okay. And P8 is 36 to the power 8. This is the number of strings of length 8 which contain any character, and I want to remove from them the number of strings of length 8 which contain only letters, English letters. So we got to P6, P7, P8, and then the total number of passwords, as we've seen, is either the passwords of length 6 or the passwords of length 7 or the password of length 8. Okay, so you know what is this. This is 36 to the power 6 minus 26 to the power 6 plus 36 to the power 7 minus 26 to the power 7. Okay, plus 36 to the power 8 minus 26 to the power 8. So this is the answer of the question. And here, to answer this question, we used the sum rule and we used the product rule. And this is the art of counting. We are counting the number of passwords, valid passwords.